Welcome to this short clip where I'll discuss the answers of question 30, 31, and 32 of paragraph 7.4, I thought? No, 7.3. I'll read out the questions and I'll give you the answers, and I'll give also the explanation for the answers when it's necessary. At question 30, the isotopes that are generated by radioactive decay can also be radioactive. Sometimes there is a whole chain of radioactive isotopes which follow each other one by one until the final decay reaction gives a stable atomic nucleus. Figure 29 shows you 6 steps in the decay chain of uranium-238 as it decays into stable lead-206. Some data has been left out in these steps. Write down what is still missing in step 2, 3, 12, 13, and 14. Well, at step 2, you'll see that the numbers. Am I correct? Yes, it's an electron because it's 0, and minus 1 e, and that completes the numbers. 234 before the arrow at the start of the reaction, and you've got 234 after the reaction at palladium Pa. So the other number should be 0, and then it's in balance. And the other side, you've got 90, and at the start of the reaction, and at the end of the reaction, you've got 91. So then there will be a minus 1 at the other side as well. So 91 plus minus 1 equals 90, and then it means they are complete. At step 3, this is the answer: 234 and 91 palladium. The same reason. 234 at the end of the reaction plus 0, so that equals 234, and 92 plus minus 1 equals 91, and the substance is Pa. At step 12, it's 210, same reason as the steps before. Step 13, you've got 210 83 bismuth, and that you can complete that at the end of the reaction because 210 plus 0 equals 210. And you've got 83 at the start of the reaction, and what should be on the other side, it's 84. 84 plus minus 1 equals 83. And at step 14, these are the answers: 210, 84 polonium, and 42 helium. At question 31, radioactive decay can be described with a decay equation. On page 277, you will find examples of these. Give the decay equation for plutonium, atomic number 94, changing into uranium by alpha decay. Well, this is the decay reaction. You should know the atomic number, that's the bottom number, and the atomic mass is given because it's plutonium 240. Because it's an alpha decay, it's always a 4-2 helium nucleus. And the other numbers you can calculate because the numbers should be equal to each other at the start of the reaction and at the end of the reaction. So 92 plus 2 equals 94, and 236 plus 4 equals 240. Alpha decay is always this particle, always a 4-2 helium particle. At question B, nickel 63, atomic number 28, changes into copper, atomic number 29, and that's a beta decay. This is the equation for 6328 nickel becomes 6329 copper, and because it's a beta decay, the mass number won't change. So 63 at the start and 63 at the end. Only the amount of protons and the mass, the atomic number changes. So 29 plus minus 1 equals 28. Question 32. Read the text in figure 30. It's a fragment from a textbook. Explain what particle is emitted in the decay from P to Q. It's an alpha particle because the atomic number decreases by 2, and that means it's a helium nucleus. What particle is emitted in the decay from Q to R? And that's an electron because the atomic number increases by 1. At question C, which two nuclei of the series P, Q, R, and S are isotopes? And that's an important one, P and S, because they have the same atomic number. And because they have the same atomic number, it's the same substance, and that means they are isotopes. Well, these are the answers for question 30 till 32. If you still have any questions left, please use Teams or Magister to send me a message.